Welcome to the DIY Honda Garage channel. DTC P0420 stands for Catalyst System Efficiency Below Threshold, indicating a potential issue with the catalytic converter's performance on the Honda Civic models from 2006 to 2011. The catalytic converter plays a crucial role in reducing harmful emissions by converting exhaust gases into less harmful substances before they are released into the atmosphere. When the emissions output exceeds the expected threshold, the Engine Control Module, ECM, triggers the DTC P0420. It's important first to record freeze frame data and any onboard snapshots before initiating troubleshooting. Notably, this DTC may appear alongside other codes such as P0137, P0138, or P0141, which pertain to the secondary O2 sensor and its heating mechanism. Addressing these associated codes is essential prior to resolving the main DTC P0420, as they can provide further insight into the issue at hand. The error associated with DTC P0420 is primarily due to the performance issues with the catalytic converter. This component is integral in meeting emission standards by transforming harmful exhaust gases. The secondary oxygen sensor, HO2S, located downstream of the catalytic converter, monitors its efficiency by comparing the oxygen levels in the exhaust before and after the catalytic conversion process. If the sensor detects that the converter is not operating within the required thresholds, it triggers the DTC. In addition to the catalytic converter, the secondary O2 sensor itself can contribute to the problem if it's malfunctioning or if the heater circuit fails, resulting in codes such as P0137, P0138, or P0141. Therefore, pinpointing the exact component failure is necessary for effective troubleshooting. DTC P0420 can be attributed to several underlying causes. The most common reason is a failure of the catalytic converter itself, which may be due to age, contamination, or physical damage. Another possible cause is a malfunctioning secondary oxygen sensor, which can provide inaccurate readings, thus leading to erroneous DTC triggering. Poor fuel quality is another contributor to this code. Low-quality fuels can lead to incomplete combustion, ultimately affecting the catalytic converter's efficiency. Before proceeding with troubleshooting, it's essential to rule out these causes and consider the implications they may have on engine performance and emissions output. The presence of DTC P0420 typically results in several obvious symptoms. One of the most notable indicators is the illumination of the check engine light, CEL, on the dashboard, alerting the driver to a potential issue. Additionally, vehicles exhibiting this DTC may experience decreased fuel efficiency as the engine compensates for perceived inefficiencies in the exhaust system. A rough engine idle could also manifest, as the engine may struggle to maintain optimal performance under varying conditions. Recognizing these symptoms is crucial, as they can guide the technician toward identifying and resolving the underlying issues associated with the DTC P0420 efficiently. The first step in addressing DTC P0420 involves turning the ignition switch to the on position, allowing electronic systems to initialize. Following this, the Diagnostic Health Scan HDS tool should be used to clear the current DTCs, resetting the vehicle's computer system. Once the DTCs are cleared, the engine should be started, and the technician must hold the engine speed at approximately 3,000 revolutions per minute, RPM, without any load, which means that the automatic transmission should be in park or neutral position. This step is crucial, as it allows the catalyst to reach a certain temperature, and the vehicle's radiator fan should activate during this process, indicating that the system is adjusting properly to the engine's operational conditions. In this step, A test drive should be executed while observing specific conditions. The engine coolant temperature must be above 158 degrees Fahrenheit, 70 degrees Celsius, ensuring that the engine has reached its optimal operating temperature. For automatic transmission vehicles, it is essential to keep the transmission in drive and achieve a consistent vehicle speed ranging from 45 to 75 miles per hour, mph. This range should be maintained for at least 5 minutes, preferably while cruise control is set for better speed consistency. For 2009 to 2011 models, additional parameters include driving between 55 to 75 miles per hour for 10 seconds, followed by deceleration with the throttle closed. This step confirms that the exhaust system components, including the catalyst, are functioning correctly under driving conditions. After completing the test drive, the technician should monitor the onboard diagnostics (OBD) status via the HDS tool. At this stage, it is crucial to determine if the screen indicates executing, which means that the diagnostic test is actively running. If the test is executing, the technician should proceed to the next step. However, if the screen shows out of condition, it suggests that the vehicle did not meet the necessary conditions for proper testing, prompting a return to the previous driving step. Should the status indicate passed, it would imply that the system is functioning adequately at that moment, while failed would indicate that further diagnosis is necessary to isolate the issue, leading to DTC P0420. Continuing the test drive is essential to ascertain the vehicle's OBD status. As the technician continues to drive under the previously established conditions, the HDS must be monitoring for a status update regarding DTC P0420. If the OBD status indicates failed, this result requires immediate attention and signifies that the problem persists, necessitating further investigation or replacement of components. Should the screen display passed, it may indicate intermittent failure or acceptable operation for the time being. If the status shows executing, ongoing monitoring should be maintained for a result, while an out-of-condition status would call for a return to earlier troubleshooting steps. Upon determining that the DTC P0420 has not resolved through the initial troubleshooting steps, the next action involves turning the ignition switch to the lock position, effectively shutting down all electronic systems. The technician must then proceed to replace the three-way catalytic converter, TWC, if it is deemed ineffective based on prior diagnostics. After the replacement, turning the ignition switch back to the on position is required, followed by utilizing the HDS tool to reset the engine control module/powertrain control module, ECM-PCM. This reset ensures that the newly installed catalytic converter is recognized by the vehicle's onboard computer, allowing it to function correctly. After resetting the ECM-PCM, it's crucial to perform the idle learn procedure. This process allows the engine control module to recalibrate the idle settings based on the new conditions established by the updated components. Following the idle learn, a test drive should span approximately 10 minutes, where the driver must consistently vary the vehicle speed to mimic real-world driving conditions. This variability assists in adequately calibrating the newly installed catalytic converter, ensuring that the ECM can effectively monitor its performance. During this phase, maintaining awareness of any unusual behaviors or warning indicators is important to determine the effectiveness of the repairs made. In this final step of the troubleshooting process, it's vital to check the CATA monitor condition in the data list using the HDS tool. This step is critical because it allows the technician to assess whether the newly replaced components are functioning properly. If the condition is deemed okay, it indicates that the catalytic converter is operating effectively and keeping emissions within acceptable limits. Conversely, if it shows no, it will necessitate rechecking the previous steps to identify any underlying issues that may still be affecting performance. This verification process ensures that the repairs undertaken have fully rectified the issues associated with DTC P0420. The final repair verification phase involves ensuring that no new or existing error codes remain in the system after completing all repair procedures related to DTC P0420. Utilizing the HDS tool, the technician should perform a comprehensive scan to confirm that the codes have been cleared and that the check engine light is no longer illuminated. It's essential to conduct a short test drive to validate that the repairs have restored system performance to normal. If all systems are functioning correctly without triggering any new DTCs, the entire repair process can be concluded with confidence that the issues have been resolved appropriately. Preventive maintenance is a critical aspect of ensuring the long-term health of the catalytic converter and associated emissions components, thus helping to avoid DTC P0420 in the future. One of the first steps is consistently using high-quality fuel, which can significantly minimize the risk of buildup or contamination that leads to catalytic converter failure. Regular emissions checks should also be part of the vehicle's maintenance schedule, as they can identify potential issues before they manifest into warning codes. Additionally, it's advisable to monitor the health of the oxygen sensors, as they play a pivotal role in proper engine function and emissions control. Proper maintenance not only extends the life of these components, but also enhances overall vehicle performance. In conclusion, DTC P0420 signifies a critical issue pertaining to the efficiency of the catalytic converter in Honda Civic models from 2006 to 2011. This DTC can commonly result from a faulty catalytic converter or oxygen sensor. Following systematic troubleshooting steps is essential to accurately diagnose and rectify the issue, beginning with clearing existing codes to monitoring OBD status. Emphasis on preventive maintenance can significantly mitigate the risk of encountering such error codes in the future. Overall, understanding the implications of DTC P0420 and implementing thorough troubleshooting protocols ensures that the vehicle remains compliant with emissions regulations and maintains optimal performance. Please like and subscribe to the channel. See you next time.